Yeah, this one, random popping circles. All right, let me quickly just gonna copy paste that. So this is our problem statement. Okay, so write a Python function. And so I have given you guys a name. Okay, and to draw a circle of given color with a random radius. So what is the input here? Inputs. Um, input to a function. Not draw circle. So this, yeah, this function, yes. Of course, you need the radius and you need the location, right? But are they inputs? Yeah, right. Only the color is input. Why aren't they inputs then? Yeah, so we have to generate those numbers randomly inside the function, right? So so only given color is given word is there, right? So that means that's the color is the input, the word given recognizing that. Okay, all right. So so that's the input. So let's write that. And we're gonna basically later on we're gonna make the color also random. Okay, all right. Um, what is the output? Yeah, basically, a random circle, right? Okay, that means a circle with random radius at a random location. Okay, all right. So matches. Yeah. Okay. So I already written that. Okay. So sorry. See. All right. So that's a good one. Why it's a good match? Because it uses circle function and colors and yeah, go to function, right? So those are matches because it can basically tell you, okay, so this probably need help us, right? Okay, so so I'm gonna go over here and we can kind of try that out. Okay, so all right, so the turtle is right here at 0 0. All right, and let's say we generated one random point right here at, let's say, 50 50 randomly though. Okay, so we're gonna start drawing from there. So we'll have to tail up, right, and then tail up, and then move to this point, right? So go to, right, and then draw the circle, right? So so we have to figure out both x and y randomly, and then the radius randomly, right? Once you figure out the radius randomly, we can draw that circle, right, like that. That's it. So that's our function. So this is actually a rather simple one. Okay, so so let's go and write our plan. Okay, all right, step one. Well, I already have it. Input, we have to first input the color, right, because it's an input, right? Okay, all right, step two. Before that, tail up, right? Okay, so tail up, and then 2 3 go to random location, right? So go to, oops, all right. Now this I would say a compound step, because we have to go to random location, so you have to generate these two, right? So I would say, so 3.1, okay, generate x randomly, right, and then generate y randomly, right, right, and then move to xy, right? So okay, so 3.3, right, and go to xy, okay, all right. Okay, so now what do we do? Step 4, yes, tail down, and then yeah, draw a circle, right? So draw a circle of random radius, right? And this is also a compound step, okay? So 5.1, generate radius randomly, right? And then 5.2, draw the circle, right? All right, all right, okay. And you can see that, right, once you have this, you know what to do specifically, right? You're not looking at a paragraph of just a jumble of words, right? It's a prompt. You are not looking at this complicated prompt. You have now a recipe, right? A plan that you can, you know, go one by one, step by step, right? And then translate. So that's why I every time I do this, guys, insist, like, get here first, and then then do the translation, because you are learning the syntax of the language, so translation is going to be easier than comprehending to solve the problem, which is more cognitively demanding, okay? So, and doing it all the same time, it's really hard, like, you know, solving the problem as well as translating from English to Python, okay? So I recommend doing it separately, okay? Yes. Yeah, solving the problem is the hardest. Coding is easy once you we are learning the syntax, right? So translation is rather easy once you know the syntax, okay? So it's like, you know, like learning Spanish. You already know English, and then you are learning Spanish. You are translating from English to Spanish, okay, or vice versa, okay? It's like that. But thinking in Spanish is kind of hard when you learn Spanish, right? So I would say thinking in Python is rather hard when you're learning Python, okay? And when thinking Python means you are actually trying to solve the problem by thinking directly, by directly coding it, okay? All right. So okay, so so let's now translate this algorithm to code, okay? So I already have the docstring written, okay? So line number 1, translation, okay? So color is the input, okay? Sorry. Input, yeah. So I'm also passing the turtle usually. Yeah, that's turtle. Tom is turtle. Yeah, 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 yep. Pin up, right? So Tom dot up, right? Dot up. Then this one, right? So go to random location. So, you know, over here I'm really explicit, right? But in coding we can actually do all of this in a single line, which is totally okay, okay? So I'm going to actually follow that way. It because one thing, it's actually elegant. The other thing is, in here you don't have to create this xy as variable, because there's only one place we use x and y, right? So we directly gonna have those values. Okay, so so basically I'm going to, so one thing, we need to actually import this random module. So have that. Okay, make sure you have it. You don't need to import, you can, either way is fine. Yeah. Okay, so you can put as many you want to import, like comma separated all the way. Okay, no, it's turtle has it. Yeah. Okay, all right. So well, turtle don't have a random color, but we're gonna actually learn how to get a random color. Okay, all right. Okay, so so the function is go to, right? Tom dot go to, and then it's x comma y, but this time it's need to come as randomly, right? So it's random. So this is gonna be x, right? Random dot rand int. Okay, follow me, guys. Okay, so and then we're gonna create. So this is x. Okay, and then there's going to be y. So I'm gonna put y over here. So so in here, so this is x, and this whole thing is y. So this whole thing is x, this whole thing is y. Okay, all right. So now we need some domain knowledge over here. I think in the turtle it's actually negative 300 to positive 300, both x and y. And we can actually find out specific parameters. And then that means our circle can be within there, right? So and then if let's say our maximum value that we're gonna get for radius is like 100, so then basically less than 100, right? So I'm gonna use like negative 200 to positive 200. Okay, so let's use that. So I'm gonna say negative, so the range is going to be negative 200 to positive 200. Okay, and then in regards to rand int, they are all inclusive. Okay, so you can also get 200 randomly, right? They are all inclusive. Okay, no, because it's coming from this guy. Yeah, it's like turtles, right? Turtle dot up, it's like turtle dot go to, right? Similar to that, right? So see that module name, and see here module name, right? Dot module name dot, so module name dot, it's the same pattern. Okay, and we use the dot notation to access the attributes of that module, in this case randint, and we're going to learn a bunch of others later. Okay, any questions? That's a good question. Okay, so this is a value, right? Right, this is a value. So well, it's a random number, right, between negative 200 and positive 200. Okay, so well, if I create a variable x equal that and then pass x, it's okay. But why creating variable where we can directly call the function there, right? Because remember, we learned that function calls are expressions, right? So this is an expression, right? So if I use like 50 over here, this is an expression, right? This 30 expression, right? Right? So function calls are also expression because they are returning a value, right? So that value, so basically, so I'm going to say, so you can directly use your function call there, right? So no, it's not a mistake. Like, yeah, if you do this, if you do this x equal this whole thing, okay, I mean, I'm glad you asked. All right, so and you can basically use x over here, totally fine. No one can argue that. Yeah, so what I'm saying is that you don't have to create a new variable, because we are using that variable only one place. So why not use the value, right? In mathematics, we create variable because we're gonna need to use it in some several places down the line, right? That's when we create variables. Here we don't do that, so we can basically use just that value. Okay, so I'm gonna basically do that. Okay, all right. Okay, so that's, now we went to the random location. Now we can um, um, draw the circle, right? So yeah, so Tom dot down, right? And then Tom dot circle, right? Yeah, it's good. Yeah, I'm gonna add that. Yeah, we are adding that. Okay, but now the radius also going to be something like that, right? So you can directly pass it as a random value. Okay, and I'm gonna use this time, so 0 2. So 0 means a dot, right? For the circle 200. Okay, so that's the one that I'm going to get. Okay, all right. So now let's add the colors, right? So Tom dot fill, sorry, begin fill, right? And then Tom dot end fill, all right. And then and basically I have to, after this um, should be fill color, right? And that's gonna be the color, right? Okay, all right, that's it. Okay, so let's check this one out. I'm gonna leave it like that for you guys to take a look. All right, so let's try this one over here. Okay, so I think this is like this. Oh, I think I have it already. This is the one. Okay, all right, all right. What do we call these two parameters? Another name? Oh, not public interface, no. Actual parameters. So these are either actual parameters or just plain arguments. What do we call these? These? No, not arguments. No, just parameters. Or the other name? Formal parameters. Formal. Yeah. Think of, like, think of this is your recipe, and then these are just things are mentioned in there, like, but now you are following the recipe over here and then creating the bread. So this is your flour and then maybe the baking time kind of things, your actual values that you are going to use. Okay, all right. So let's run this. All right, so got the one, right? So if we're gonna run it again, you will see that it's randomly appearing in a random location with the random radius, right? So it's randomness working. Okay, all right. So the next question is, next part is, write another function named draw random circles, guys. Okay, be really careful. Okay, see that it's plural, right? Circles, here it's circle. Okay, so another function, so we have to call it 5 times there, right? So simply, basically, we create a new function, this one, and then we call this function 5 times, right? So okay, so and if you want, you can actually, create a plan for that one as well. But if you see that the answer is obvious, just go for the direct coding, because you kind of have solved the problem mainly, right? So it's up to you. Okay, so I'm gonna call this guy, so like this. Okay, and right here. Okay, so this is one call. Okay, all right, so it should be 5 times, right? So we're gonna call 5 times. That's it. Okay, I'll add the docstring later, guys. Okay, so well, okay, so this should be color, so I should have, otherwise it'll be red actually. All right, now if we call this one, so this one, so I'm going to block this one, and call this one. All right, and we'll get bunch of circles, right? So I pass blue, so in color blue. Okay, all right, okay, all right. So how do we make the color also random? So now color is blue, right? What is it? Turtle dot? There's no turtle called. Yeah, so there's no random color choice in turtle. Okay, so we'll have to figure it out. So ideas, and also we cannot use the thing that we haven't learned. Okay.
Well, we imported random, so
Mhm.
I mean it's going to be some function of random attached to the function of color from Turtle.
Yes, yeah, you're right. So we need to find that one. Okay, so that means you have to explore turtle documentation. Okay, so it's right here. So I actually got that one. Okay, see that this RGB, and here's an example. Okay, sorry. Okay, so and then RGB values from 0 to 255. Okay, so they are numeric values, so we can actually generate them randomly, right? That's it, that's all that. Okay, so basically it's the number is basically from 0 to 255, the range in the rand int, right? So let's do that. Okay, so we're gonna go over here and then change that. I'm gonna copy paste this function and then create a new one with this name. Okay, all right, so 2. Okay, and now the color also random, so we get rid of that, right? So okay, because we are going to generate the color inside, right? So instead of this, what do we have to do for the color? It should be RGB, two values, right? Three values, right? So right, so for this we're gonna use random dot rand int, right? So the red value is going to be 0 to 255, right? And then same for all the three, right? So G green value that, and blue value that. Okay, all right, that's it. That's the only modification. And then we can now call this function. So I'm going to write a new function that with the same okay, with the color also, right? So um, this one, and it's actually the circles 2, the second one, and then we're gonna get rid of that. Okay. All right, this should be actually 2, right? So second function, so only 2 actually. Okay, so all right, so that's the this function now. um, so let's try this one. So it's this one. So I'm gonna block this one, and then open this one. Okay. All right. So let's try this. Oh, I made a mistake actually. So let's read it. Type error. No random circles 2 takes exactly 2 argument 1 given. So actually I think I made a mistake right here, because yeah, so we don't need that, right? See that I have given 1, but it was expecting 2. So that was, so the type error means, the type of the two functions not matching, right? That's why. All right, so it's working. Okay, so all right, and you can see that, like, sometimes there's a still um not anything wrong, but we can still improve this one. It's like, how do we, sometimes all colors can be really similar because they're all random, right? And then differ by maybe either we get the same random number always, or really close. So how do we get 5 distinct colors is my question.
You can make a variable of colors and manually put it in
Well, the
yourself.
thing is, yeah. The thing is, this, when you create, right? So when you create random variables using randint 0 to 255, there's a good chance that you get um, all colors, um, all three values, all three RGB values same. That means it's gray value now. So color is gray. So how can we give it a depth of colors? Yes.
Change the ranges on each of the colors.
Yes. How do we do that?
You can set the range to, every time you call it with a different range of colors inside of the
Okay.
random int.
Okay.
Function. Like maybe the first time you call it, it's like 0 to 50, then the second time 50 to 100, whatever. Doesn't that make it
Yeah.
less random?
You can do that. Yeah, you can do that. It's a good point. But then the thing is, then now you are restricting one part always to a region, right? So my point is, this RGB values, they're all random, right? So randomness means there's a possibility that all three can get same value. So that's a gray now, right? So, and then the other problem is the colors, and then for every circle that can happen. So now they don't have a color depth. Instead, they are really close, but our eyes even can catch the difference. The contrast is really small. My what I want is to get a bigger contrast. How can we do that?
I mean, we have to make it less random.
Okay, so this is one solution. Okay, that we didn't learn actually. I didn't give you the code for that. It's actually the rand range function. Okay, so let's use that. So I'm gonna chain this to, okay, so I'm gonna chain this to rand range. Okay, so and then it allows to give me a gap, like let's say 10 difference. Okay, so I'm going to try this at right here in the in probably over here. Oh, not here. Oh, let's do it over here. Right here. Right, I already have it. Okay, so see that, right? So see that when I run this, right, the numbers I get in steps of 10, but they're still random, but I don't get 11, right? So I have gaps between the values. Gap is 10 always. So first run I got 10, 10, and then 90, 140, 190. There was no 141, no, right? So it's because this guy is kind of controlling it. So we can do that way, then, and we can get two like distinct colors, right? So that's the idea. Okay, so let's try that. And then real quick, I'm going to change all of these to that. Okay, And I was not expecting this from you, because you didn't know that, right? You didn't learn that, right? So it's first time you are learning rand range. Okay, so and that's it. So we can try now, and then we can actually see that, like, we'll get really nice different colors. Okay, so right, kind of avoiding gray values kind of thing. Yeah, okay, that's it. All right, any question? And here's the code again, guys. Okay, so this the function. And we're going to learn more about range function, rand range, and rand int later. I think in the next module actually. Okay, all or not 7 type module. Okay. Yep. I want to go slow in this class to catch up with the other, but I think going even faster. How is the midterm going? Did anyone get access? Like, did finish the one that yeah, library thing? Guys, if you like, it's not an excuse, right? If you, let's say, this midterm, right? So this access from top to bottom is enforced, but that doesn't mean that you can't access without doing the top. You can get a 0 always. Submit it empty. All right, you can submit like any screenshot you have, and then you can basically, I'm saying that you can cheat canvas and get access to the next one. So it's not an excuse that it's actually blocked. Okay, so say you're not ready to do this one yet, but you want to see what the midterm is. So you basically submit this one empty, and then this will open access to you, and then take a look. Okay, and then come back later and then finish the library assignment too. I'm totally fine with that. You had a question?
No, never mind. I figured it out. Like, didn't have access to do the manager stress first, and then after.
Oh, okay, yeah. So you got, yeah, you just did the same, yeah,
Okay.
yeah,
Okay.
yeah. So suggested deadline is March 15. So you have 1 more week. Okay. So, but I think I will have to grade this before 21st of March, and then pretty much I have to submit whatever the grade, basically whatever the class by then, March 21st. That's your midterm grade, not just midterm project grade. No, until to March 21st, what we have done, the all concluded deadline until March 21st, that's up to that is your midterm grade. Okay. Yes.
You've given us a lot of extra credit. Will that be reflected in the midterm?
No, unfortunately, because it will be reflected in the end. The reason is this, right? So it's an extra credit assessment component.
No, you mentioned
But
that.
yeah, so basically if you don't submit it, then it's gonna weight you negatively. So it's not extra. So basically, let's say you didn't submit, you have a 0 for extra credit quiz. Now it's gonna um, negatively weight you because it's 5%, right? So what I will do is, in the end, basically I am going to excuse everyone who didn't submit and then wait. So that's just gonna not gonna affect those who didn't submit, because it's extra credit. It shouldn't weight people, right? Okay, that's fine. Yes.
So if we want our most accurate grade, we should get caught up to the midterm by the 15th and have everything so that we can get our real grade for the midterm.
Yeah, I mean, I highly recommend that, trying to get that, like, but some of, like, for example, like, it's say module 8, right? And it says March 8 to 15. For this class, no, we haven't started module 7 yet, right? So we are behind because these are preset dates. So I'll figure out, because but I won't I do basically I will not consider, like for example, module 8, even though it's before midterm.
For sure.
Yeah, because we haven't done anything, right? Yeah, so I'll be mindful on that. Don't worry about that. Yeah. So unfortunately, some, like for example, let's say March 6, like this one, right? So this one has a deadline March 8, right? But we will not be able to finish it today, right? So and then it's still, since the deadline passed, Canvas is going to put a 0 when you don't submit, right? So it's kind of unfortunate. That's what Canvas does. But I'll manage that and get you a actual midterm grade um, when when I submit 21. So it will be mostly reflective, I would say. Okay, not the exact position, but mostly reflective. Okay, yeah. Any questions? All right, so let's start our next chapter, guys, which is the data. And we can go fast on this actually. Um, and then it has a lot of sections, and some of the, so in almost entire chapter is conceptual topic. Okay, so we can actually go fast, and I can let you guys read this and then understand this stuff. Yeah. Okay. Oh, by the way, guys, so next week, this class is rather okay, but we're gonna have a kind of a workshop in the class, meaning we'll take about 40 minutes, and then I'm going to ask everyone to open your programming assignment. We have 3 or so far, right? Module 4, 5, and 6. So it's up to you to get help from which one. So you're going to open it, and then you're going to go around and check everyone and help everyone. Okay. So this class, I know it's not that big of a problem, but the other class is way behind, like 50% of the class. So yeah, depending on that, probably we'll say we'll take less time here in this class. But yeah, so that's the plan. So part of the lesson going to be, we're gonna, all of 3 of us and then me, going to go over and check your programming assignment. Okay. All right. So I think we only need to do one day. So going forward, we'll try to do another day like that, and because that's where many are behind, and that's the most significant also in the class, because you have to, from the thing that you learn, you have to solve that problem. That's the creation part, right? So you have to create, you are solving your own problem, right? The one new problem given to you, so which is the most important thing you take away from this class. So we have to make sure that you get there. Okay. All right. Okay, so let's start this one. Questions before that? No, right? Okay. All right. um yeah, so there are some data. This model is about data, and then one place we generate data is actually through simulations, and then there's a couple of already, and then one good reason for simulation is sometimes doing a physical experiment is really expensive, right? Imagine, and also impossible sometimes. Like for example, um, you know, um, how about the, like, for example, the Big Bang, right? There's no way to test it out, right? Because it's already happened. So there's no way to do an experiment of Big Bang. So you can actually simulate the Big Bang, and let the simulation run and collect data. So that there are even now simulation about the universe, like the birth of the universe, and then you simulate it and then you get data. Okay, so you can do that. And then also, you know, you don't have to wait 4 billion years, right? So over 13 billion, right? So from the Big Bang, you can actually do it in a computer and get up to that time point, the current time point, right? So those are benefits of those, right? A lot of benefits of that, and not just complex at that. You can, you know, you can simulate other ways as well, like, you know, put sensors in dummies like this and do crash tests, right? So you don't have to put the actual human, right? So there are a lot of applications of those. Okay. All right, and then there's some more examples as well. So I'm gonna move on. All right. So right now, we have the term called big data, right? So the name is, they are large actually. So right now the entire web is in the zettabyte range. Okay, so 10 to the 21 bytes the storage, um, worldwide data collected per year, kind of. Okay, and then there are some, these are some sources of data, and social networks, traditional businesses, and then this one right now is becoming really common, right? Internet of Things, right? Your TV now a small computer, right? And Google now sell Google TV, right? So they team up with Sony and selling a Google TV. So it's actually, you have to sign up with Google and use a Google account to log in and things, right? So they collect now through the TV as well, right? So we thought, you know, privacy is screwed up through the computer, not anymore, right? So, all right. Since we have big data, then companies want to make money and other things, and the government want to do, check patterns and things, and we have data analytics. Okay. And it's a nice story of that, and you may have watched this film, the Moneyball. I think Brad Pitt got an award for this one, or maybe the movie, right? So the Oakland A's did that actually, back in that time, and they use statistics to, all sort of statistics, to pick cheap players but good, right? Like trade, and also I think the patterns of player, you know, playing patterns, like, you know, how the guy hit and things like that. Okay, so and they almost got the world, thing, but I don't think they win the World Series at that time. I'm not sure though. They're no longer here, right? Yeah, where did they go? Las Vegas. Okay, and then same for, Raiders, right? So the both team betrayed Oakland, right? Well, I guess I don't know. I mean, it's a loss to the city, though. Yeah, right. Big loss. I mean, I remember May even flew to Las Vegas to get, at least keep keep Ace. Yeah. Anyway, okay. Because, you know, their data says a lot of money people bring when they play in Oakland, right? A lot of ways, right? Some people fly to Oakland, right? Big amount, right? All right. But that was not the reason. I don't know. I don't know.
The Raiders never won, but everybody who liked the Raiders
Yeah. All right. Okay. So this is an important topic. So let's spend some time in here. So there are ways to visualize data. Okay. So I mean, why we need to visualize data is this first paragraph explains that. let's say this is our data set, and it's actually mentioned over here, right? Like this there are some data over here, but you can see that, right? It's actually really hard to comprehend, right? As given like in a paragraph. So obviously in a paragraph is not the way to visualize data. Okay, all right. So this is a big no-no. So in a report, if we actually write our data like this, and then probably, you know, it's not a good report. Okay, so instead, one way to visualize it basically in a table, and then this more explicit, right? So the count is visible properly in a column, and then median house prices visible, and we can also see a simple pattern. You know, Orange County has the highest, right? So the median house prices, right? So, but if we use to tabulate our data set like this, this is a big one, and this is also not good, right? So table is okay for this simple data set, but if we have our data set like this is also not good, because we don't see any pattern here, right? So, well, the thing is, you know, it's the way actually our human brain wired, right? It's visual, right? So we use the what we see to um, make a judgment mostly. So, and then what we see here is bunch of numbers, and then kind of we can. It's not a visual pattern. Okay. So, but if we use a scatter plot like this, well, now it's actually telling a story, right? What's the story here?
From 2000 to a little past 2005, it went up, then it took a big dip,
Yep.
then it sort of stayed the same for a little
What happened?
price.
Yeah.
Market crash.
Yeah, the housing bust, right? It's basically that's the here it happened, and then in the United States dragged down the entire world in the end, right? So it's the housing crash basically, right? So we call the subprime mortgage thing like bundle, right? Blunder, right? So so it started in 2008, and it last almost like up to 2012, 11, right? Ish, right? So and it's a what do you call the um, recession, right? It's the recession. So yeah, so so that's what happened, and then we don't see that in here, right? In this table, but we see that pattern here. Okay, so that's the advantage of, you know, plotting your data over tabulating it. Okay, all right. So it's 12, guys. So let's take our break. 5 minutes, 6 minutes. Let's take 6. Oh, yes.
Okay.
Yeah, it's working.
Okay. I finally got it working.
Mm-hmm.
But so
What do you want to do?
so this is what the code looks like,
Mm-hmm.
and I have these two lines here, and these two lines here are identical, right? They're the same thing. So,
Mm-hmm.
but if I want to delete this one,
Mm-hmm.
it stops working. And I'm thinking like, do I have to have the line twice? Do you
Oh,
know?
okay. So the reason is this, right? You created separate variable for radius,
Mhm.
right? And if you delete that, and then basically you are using a variable, but where is the value of it? Here's the value, right?
All the way up there, right?
No, it's no. It's basically this is main program, right? So it's different. So this is independent. This one is independent. And why? Okay, I wonder why you actually created a main. We are basically running it in the main program, right? Okay. Yeah. So basically, you didn't create a new function. that I asked, like, let's say, do we have the prompt here? Let's get the prompt. Alright, home. So say that I asked to write a different function.
Oh.
So but you did it in the main program, which is fine, but it's basically that's what happened. Okay, so is that this one or this one? No, this one. Okay, so I would say, um, so um, one thing that, okay, so basically you create a new function called circles and then do this, but still, I mean, the problem here is, it's not a problem. Basically, you have created a variable called radius and then assign the random value. What I did was, instead of using a radius variable, I directly put this in here.
Mm.
I mean, why? Because in this case, I think you have to, yeah, in this case, you have to, well, you don't have, okay, circle. Oh, radius should not be an input. Yeah, that's why. Because it's you radius, you also, okay, so, okay, here's the mistake.
Okay.
You input radius as well as you also create your own inside. Okay, so in based on my prompt, radius is not an input. It's a value you generate randomly inside. So this should be actually deleted. Okay, all right. So you this part is correct. You generate color randomly. You generate radius randomly as well. So yeah, so these are fine. And then when in the call right here, remove the radius. You don't need that actually, and you don't need the color as well. Yeah, and then we're gonna actually remove the color also from here. Yeah, remove the color too, because you are generating color randomly, right? You don't need to input it. So then here, remove both of these. Okay, remove both of these, and that's gonna be your 5 times calling. Okay,
Uh-huh.
yeah, so you can try now.
And then just get rid of circle two, and then oh yeah,
Yeah, yeah, there you go. Let's try what if bad input line 59. So what is, okay, let's see. Well, let's check line 59. Draw random circle. Okay, let's go to the top. I think it's
Shouldn't be a problem, right? It's fine on 57.
draw random circle. Oh, okay. So I think we are missing a turtle, right? So we need a turtle, right? So we need to pass. You see, you are not creating turtle inside. So that means you have to take the turtle inside. So let's input a turtle. This one, this guy, a turtle. Sorry. Um, yeah, yeah, yeah. So now we can actually pass this turtle, copy that, and to this, because you have to pass a turtle, right? So you have to actually pass. Yeah. Now we are good, I think. All right. Still
It's just 59.
59.
But
Okay.
it's not 58 or 57.
59. Okay. Oh, maybe it's actually. Maybe this. Let's try that. Let's see. 35 name error. Okay, so I think it's yeah, it's just a spelling mistake. Yeah, there you go. Yeah. So did you understand? Basically, what happened was, um, you pass as well as you created the same. So basically, you overrid the. So basically, you had earlier you had color, right? But then you also have color here defined, right? You didn't have to, either it's this coming through this or you create inside. But in this case, we are randomly determining the color, so we should do it inside our function. Okay, not take as a input parameter. Okay. Okay.
Today, yeah. I got like an hour. Perfect. Yeah, that should be fun. Because he's gonna also join us. Yeah, I think that there's one more of those that I haven't finished. The non-radish. Uni one radish I got. Let me see. That was one to help me with. Oh yeah, yesterday. Yeah.
How is the midterm project going?
I haven't started yet.
Okay, that's fine. I think you're good.
But I want to do the GitHub resume website one.
Good choice.
That's
Yeah.
what I'll start. This
Yeah,
week.
and then if you want, we can sit down together and then I can show you things as well.
Okay.
Yeah.
Yeah.
Go for it. Okay.
Okay.
All right. Sorry. Yeah.
So we put in the random range,
mhm.
but then they're all the same color.
Yeah, I think. Yeah, the reason is so random circles, and you're actually using violet inside.
Yeah.
So you are this is the yeah. See, you are using this function, right?
Yes.
So inside you are actually using a single color.
Oh, okay.
See, then you are calling that function 5 times. Even though you pass red, you are not using red,
Right.
and you are also not using a random color. Because you are not calling this guy inside. You have to call this guy circle 2,
Okay.
and then remove this one. Then it will work.
Okay.
Yeah,
So then
and
remove
this should be 2.
two.
Yeah, yeah. So, yeah, and copy paste the 5 times, and it should work.
Let's see what happens.
Just because
Okay, let's see.
I don't really do that. But like, for sure. There's so many options, so you can pick the one that you were the best at, for sure. Cool. Yeah, and I mean, and the GitHub one for you might actually like help you.
Yeah, let's try now.
Like it knocks.
There you go.
Oh, there we go.
Oh, it's all green
Oh,
now.
oh,
Oh,
okay,
yeah, yeah.
okay.
There you go.
There
Yeah.
goes. It's right here. There we go. Thank you for
Yeah.
catching
All right. You're welcome.
Super duper close.
Now it makes sense.
I need to do the sideboard readings.
Makes sense, right? Because you have to use that the correct function. Yeah.
It's
Yes.
time consuming.
Okay.
I need to. But I mean, the
Oh,
weekend
nice.
starts
Like
after
the color
this class,
down.
so that is true. Dude. The past couple, literally
There it
since
goes.
the beginning
Yeah.
of this class, I
Now I'm
come
gonna-
early. I get to like school at like 9 on Tuesdays and Thursdays, so we just do 4 in the full class. Cool. Yeah. But it like you need 2 hours, you know? Yeah, no, totally. But I mean that feeling of like for it is such a beneficial thing like for your learning and also like making a relationship with that teacher. So, like you can anticipate what they're gonna say. I mean, because I have math class at 9 a.m. And yeah, dude, like without the few of us that were like really trying, like that would be a really depressing. Yeah, you know what I mean? Because like I just the stuff that goes on there. Yeah. Like the dude's like playing video games. He's like, oh sorry, it's playing Need for Speed. Like if I wasn't there to look at the teacher and be like, it would be really sad. But yeah, no, preparing for the class is something that's coming up in our engineering class. He's talked about the growth mindset here. So yeah, I think what I'm really just fighting back against that time where I do nothing. Where I'm like, okay, like let me get into YouTube Reels for a while. Yeah. You know what I mean? Just fighting that or minimizing it is slowly, especially as we close in on the midterms. Just something because this is my first semester, so you know what I mean.
What's your midterm going to be?
I'm doing the data analyzation.
Good. Sit down with me and we can figure out a data set, and I can show you a few things. Yeah, let's sit down. How about yours?
I'm gonna do the
GitHub one.
I'm gonna do the GitHub as well.
Good choices. I recommend.
I've used GitHub before and it looks I like scrolled through and looked at the instructions and stuff.
Okay.
It's pretty fun.
Okay. Yeah. And then you can keep it later. I mean, afterward you can keep it as your online resume. Yeah. Yeah.
I think he's ready for a GitHub for sure. Sean's ready to get
you already know, and then you are basically ready. Yeah, that's fine. Yeah, it's
I literally like 2 weeks ago paid for a website where it was like make your resume for $2.
oh, okay,
And
okay.
I just didn't care.
Oh,
I
okay.
just needed my resume. So now I can just do that.
Yeah,
I'm
yeah.
pretty excited about that.
Does GitHub doesn't charge per month, right?
No,
Like
no.
I have
The
to
thing
go
is,
to
yeah,
my
it.
resume or
I mean,
website.
it may prompt you to pay.
Yeah, I was gonna say there's like GitHub Pro.
Yeah, so basically your code will be like open, like the open, like I think that's only that they don't allow you to create private project with the free one. So the code you put in there, like it's a resume, right? So you're gonna share it in public, right? So whether it's source code or browser page, doesn't matter then. So if you are okay with that, then go for that. I mean, if you are not, and if you want to keep your resume private, you should not
I'm
actually use.
making it public. My website's on my existing website public. So
Oh, okay, yeah, yeah.
So I mean, like, I'm fine with that.
Oh, okay,
It's
okay.
just like maybe new avenues because like Adobe's website creator is kind of like not primitive, but it's
Okay.
like bare bones.
Yeah, yeah.
And
It's
like,
actually an advanced one. Yeah.
Did they cut the funding for their website creator recently?
yeah, it's like
Yeah. So CCSF, right?
Yeah.
Yeah.
The funding for the animation.
yeah, the animation.
Yeah.
I'm shocked at the amount of data that Adobe has.
All right, guys. Shall we move on? Okay. Let's. So today, this one, this push. This particular topic, which is the tokens. I wish Cybook included that intro in your lesson. Okay, so this one. Okay, so this I'm just gonna publish this one, and you will see that it's actually um, really a fundamental thing that I wish Cybook have visited that topic. Okay, so let's take a look, and it's in module 7, guys. Okay, tokens. So we already encountered several. I mean, we encountered all 5 tokens already, but the word token was missing. So let's learn that. So I created this video using this one. So we have that free access to this. So Notebook LM from Google. I asked them. I gave 5 resources to Google, and from that 5, I asked them to generate a video, and that's what you're gonna watch now. Okay. So let's watch it. All right, but this one has you have to match 10 tokens, okay, to the correct one. Okay, so if you fail first trial and rewatch and try to get it all correct, guys. Okay, so all right, so let's watch.
Have you ever stared at a line of code and felt like you were trying to read a completely foreign language? Well, today, we're going to decode it. We're going to break code down into its absolute smallest parts, and I promise it'll make programming feel way less intimidating. Understanding these little pieces is the secret to figuring out how any code works, and, maybe more importantly, why it sometimes doesn't. So let's get started. Okay, take a look at this. This is a super common line of code you might find in a game, written in Python. At first glance, it seems like one simple command, right? Just set the player's score to 100. And yeah, you're not wrong. But here's the thing. How does the computer see it? It doesn't see one single command. Nope. It sees a bunch of tiny individual pieces. And understanding what those pieces are is the key to, well, understanding how programming languages really work under the hood. And that's where a process called tokenization comes in. It's the very first thing a computer does when it sees your code. It breaks it all down into its smallest, most meaningful parts. Let's take a closer look. Each of these little parts is called a token. You can think of it like this. If a line of code is a sentence, then a token is just a single word or maybe a piece of punctuation. It's the most basic, fundamental unit the computer can actually understand.
All right, let's start with our first type of token, keywords. Think of these as the absolute, non-negotiable grammar rules of a programming language. Everything else is built on them. So the crucial point here is that keywords are special. They're protected words. They have a meaning that's already baked into the language, and you can't use them for anything else, like naming your own variables. They're what tell the computer how to structure its logic. And here are some of the big ones you'll see all the time in Python. You've got if and else for making decisions, for and while for doing things over and over again, and def for creating your own functions. These are truly the backbone of your code. Next up, let's talk about identifiers. So if keywords are the language's fixed grammar, identifiers are the custom names we get to create. They're the names we give to our data, our functions, all the stuff we build. But you can't just name them anything you want. There are a few simple rules you've got to follow. An identifier has to start with a letter or an underscore. After that, you can throw in more letters, numbers, or underscores. And of course, you absolutely cannot use a keyword, and most special characters are off limits too. Let's see these rules in action. Player score is totally fine, but player score with a hyphen? Nope, not allowed. Underscore name is good to go, but one's name is invalid because you can't start with a number. And class, well, that's a protected keyword, so that's a big no-no. Getting these rules right will save you so many headaches with error messages, trust me. All right, next on our list, operators and literals. These two token types are like a team. They represent the actions and the actual data in your code. An operator is a symbol that tells the computer to do something. It's like the verb in a sentence. Think addition, subtraction, or assignment. A literal, on the other hand, is the raw data itself, the actual number 100, or the text, hello player. And you'll see these operators everywhere. You have your basic math stuff, like plus and minus, the super important assignment operator, that single equal sign, and then comparison operators for checking if two things are equal or if one is greater than the other. And these are the values that those operators get to play with. Literals come in a few main flavors. An integer is just a whole number. A floating point number is one with a decimal point. And a string is just text, and it's always wrapped in quotes. Okay, our final token type is separators. And just like the name suggests, they separate things. Think of them as the punctuation of your code. They help organize everything and show the computer how to read it correctly. You see these constantly in Python. Parentheses are used for grouping things or for calling functions. Commas separate items in a list. A colon is a heads up that a new, indented block of code is about to start. And the hash symbol, that's your best friend for leaving notes for yourself or other humans because the computer just completely ignores them. So we've seen all the individual building blocks. Now let's circle all the way back to that original puzzle we started with and put our new knowledge to the test. Remember this little guy? Player score equals 100? When we first looked at it, it just seemed like one simple command. But now we know better, don't we? We can actually see the individual tokens hiding there in plain sight. And there it is. The computer doesn't see one thing. It sees 3 distinct tokens. Player score is an identifier. That's a name we chose. The equal sign is an operator. It's performing the action of assignment. And 100 is an integer literal, the raw data we're working with. And this is why it matters. When you get a syntax error, it's often the computer telling you it couldn't understand your tokens. It couldn't turn your code into a valid sentence. This quote really sums it all up, doesn't it? Once you stop seeing code as this big, scary block of text and start seeing it as a collection of these simple, distinct tokens, the whole world of programming just starts to click. So, next time you look at a line of code, any code, try to spot the different tokens. You now have the key, the decoder ring, to deconstruct and understand any program out there. So the only question left is, what will you build?
All right. So the uses of data visualization, right? So basically, right, and then you can see that there are a variety of visualization techniques, right? And this topic is important, the cardinality of your data. Okay. So basically, cardinality is the number of unique elements in a data set. Okay. So that's we call the it's a technical term, cardinality. Okay. So, and you can see that over here, right? So if you compare these two data sets, which one has the highest cardinality? Second one? First one, right? And then first one, basically, in the first one, you can see that the number of unique elements in the data sets is higher, right? And that's why we have a lot of smaller pieces of the pie. And then this one, we have less, right? So which one is the better then? Like better use of plot? It's the second one, right? Because this one is cluttered, right? So use of pie chart to represent this data set is a bad choice, right? Use of pie chart to represent this data set is a good choice. Okay, and then this, and based on this, actually this module's assignment is actually created, right? So we're going to get into that actually. So then your choice of analysis, like the plotting, would make a difference actually, and then it, depending on that, you are either clear or not clear. Okay, so there are a variety of types of plots. One is histogram and then scatter plot, right? So if the cardinality is really high, and then both of these may be useful. Okay, so for example, and then this is a lot of data, and then you use a scatter plot, and then it's actually still shows us a trend, right? And then a histogram also, like there are a lot of data, but we call this the x-axis bins, right? So and then there's a one bin from 10 to 15, there's another bin from 15 to 20. We basically plot entire range of data values that fall into a single bin, like in this case, let's say 10 to 15, and then we count all of them, and then we put the total number into the y-axis. So that's why we call them a histogram. Okay, so they are called bins. Okay, so all right, so and then in here bar chart, then so it's appropriate for categorical data. So there are categories like radial velocity, imaging, and then these are basically all of them are discovery methods of planets, right? So and then the transient, right? So and then basically these are all discovered planets, and then they are basically plotting it against the method of discovery. Okay, so it's a category, right? So it's basically plotting categorical data. You can use bar charts, right? So so let's do this one, guys. Okay, so this question, all right, which chart better conveys the most common number of discovered planets in a star system? So basically what we have to choose the proper chart, so the most efficient chart that does the best visualization. Which one?
That one's pretty good. The second one looks. You scroll down on the second one.
Yeah, and you can see the difference, right? So this one? All right. Okay. So this one, basically it's a categorical data, right? So you can use that one. So this one?
That one's messed up.
Second one.
Fourth one's messed up.
Yeah. So the answer is this one. What's the answer?
That one definitely probably not.
This is first one actually, right? See that this is a bar chart, right? And you can see how cluttered that is, right? Because too many data points as categories. So if you take the wrong choice, then it will tell you what's wrong with this actually. Okay. All right. So this is this one. This one. First one, right? So then obviously you can see that this is a poor scatter plot and it doesn't tell anything. But if you use a pie chart, you can see that you can easily compare the distribution of the values, right? So and then make even a decision, right? So that's the best one. And then in your assignment for this module, that you will do the same. because you are given, I think, 3 data sets, and you will have to plot them using um, using the correct plot type. Okay, so I'll talk about that on next Tuesday, guys. Okay, so all right, so these are again conceptual topics. I'm gonna kind of run with this. Okay, but guys, please read and try to understand them. So this, I think I'll spend some time on this one if it is technical. Yeah, so this one is actually one. Okay, so this animation shows you the utility of compression. Okay, so where do we need compression? Data compression.
Files that are too big.
Okay, well, what actual use case?
Applications or pictures.
More pressing ones, I would say. Yep.
Files that have multiple different file types within them.
My question is, why we need compression? Like, what's a pressing utility? Yes, to save space in the hard drive, right? That's one. There's even more examples. Yep. All right, that's one. But I didn't get the one that I was looking for.
And what's the question?
Move where? You are almost there. Yeah, streaming, right? Streaming in the internet. So internet is still, I mean, the data is really, it's not, it's most like recently only, like, it became really fast, like 1 gigahertz, right? So um, but still the latency, network latency is big issue, right? So that's one of the reason a lot of the data type portable network graphic PNG files are used in websites. They actually are a little bit smaller than regular JPEG files, right? So so compression is important. One big use case is the internet. So you have to make your web page efficient, right? Yeah. All right, that includes streaming as well. Like streaming, if you try to stream a raw video, it'll take a lot more time actually. So the streaming service actually use different compression techniques, right? So that also, yeah, they have their own format. So yeah. Okay, so and then this animation actually shows you the value of it, and then takes actually a lot less time to load if you compress it actually. Okay, so and then also obviously the it takes less space if you compress, right? So right, and basically it's 1 megabyte, so it's now has 4. But if you compress it, so if you try to store this one, so it's, let's say it's cell phone camera, right? As the storage is limited, but if you try to store as it is, it's, you can see that only store 4 files. But if you compress it, you can actually store more, and also retrieval also easier, right? So faster. Okay, all right. So there are several compression techniques. There are main categories. One is lossy compression, and the other one is I think non-lossy compression. So lossless compression. So lossy means you lose some information when you compress. Lossless compression is you don't lose information when you compress. Okay, so one under the lossless compression, one technique is dictionary based. Okay, so what's a dictionary?
Something that holds the definitions of words.
Yeah, so basically you and then that's what we do in a dictionary, is we use the word and then the bigger description, right? So and the same idea here. So what we do is basically we create a dictionary using the words we have. Let's say in a text file, we pick words from that text file and then create a dictionary. In this case, if you read it, the letter 1 represent department, letter 2 represent of, letter 3 represent redundancy, right? So now, right, so if you have this department of redundancy department, right, so in short you can write it as 1 2 3 1, right, and that's the compression. Okay, so instead of having entire sprays, you can have this and this together. Okay, all right, and that's what it is. So let's take a look over here. Okay, so so this is the original text that I want to compress. Okay, and I create this dictionary, right? Hello represented by 1, right? My friends represented by 2. Okay, and you see that this colon, and in fact in Python that's the notation we use to represent the key value pairs of a dictionary. Okay, so so basically now given this dictionary, I can write this whole phrase like this. Let's play the animation. Okay, so this is the original data set. So I create the dictionary using like the words we have. Okay, and then basically these are built into the compression algorithm, guys. Okay, and then right, so when we actually compress, use the compression algorithm, instead of these we actually use this dictionary to put those shorter terms. So hello my friend become 1 2, and you are my friend, you are 2, right? So you can see that if we count all the characters in here, right, and in here including even the including dictionary, we have less number of characters. Okay, I think it's actually I think it's going to tell us, right? Yeah, so all of these 80 characters, 53. So in here we have 53 characters. So instead of this text file, we now have this text file, which is the compressed text file, right? And then the reduction is, the compression is 34%, which is quite significant, right? So in now decompressing, what the algorithm does is take this dictionary, and instead of 1 it's going to put hello, instead of 2 it's going to put my friends, and recover the file. That's we call the decompression. So let's say we use this file, this whole file, to send it to over a network, and once we received, and then the user now decompress using the same algorithm and then recover the original file. There's no loss here. Okay, yes.
So it's sort of like taking a piece of paper and folding it up, and then you pass it to somebody. You're passing them a smaller piece of paper, and then they unfold it.
Kind of, yeah. Yep. Okay. All right. So that's actually the LC compression. So that's come from the two inventors, Empel and Siu. So LC compression. The other one is Huffman coding algorithm. So basically, it's actually figure out the usually the pattern of the letters. Like if it is text, letters A and E are really common, right? And then Q and Z are rather used rather infrequently, right? So basically we give a smaller byte value for frequent letters like A and E, and larger byte value for infrequent values like letters like Q and Z. Okay, and then we use that. Okay, so let's take a look. I mean this one, let's take a look over this one. Okay, so first one, guys, dictionary base. Okay, so we need to give the dictionary below for LC algorithm. What uncompressed phrase do these numbers represent? 1 3 2. Oh my gosh. Okay, so this one. All right, second one. Given the following uncompressed text, which LC dictionary yields, which LC dictionary yields greater compression? Okay, he sells seashells. Okay,
I mean, the first one has more compression, but it doesn't carry the name.
yeah, which one is then second, right? Is it second? So one else. So that basically it become, so what you have to do is you have to use the dictionary and then compress it actually. So this one else, right? So then he S1, right? And then C and one SH1, right? But if you use this, let's see what happened. E and S. So yeah, right. So H1 and 2. Yeah, a lot of characters, right? So it's the first one. Okay. Yeah. Okay. All right. So I'm gonna go to jump to 4. Number 4. It's a Huffman coding one. Okay. So what uncompressed letters do these bits represent? So 01 is A, 001 is B, and then 000. This whole thing is Z. So A, no, A, yeah, A, right? BZA. This one? Okay. All right. So in zip files, it's basically a common compression technique. And you guys should read this, okay? These are conceptual. So, and then, okay, so lossless and lossy compression. So, what can anyone give me an example of a lossy compression? So Huffman coding and then LC lossless, right? Yep.
I think like you're listening to files on like music streams.
Yeah, MP3s are compressed, right? JPEGs are compressed, right? So JPEG, right? So what JPEG stand for? It's an acronym. Okay,
Joint photographic
expert group. Yeah, so that's a working group that who created the technique. Okay, they're still active. Yeah, they're, it's a kind of, like, the World Wide Web Consortium. It's a bunch of computer scientists, and then get together and then do things, propose protocols for the internet, right? Similar kind of people. But it's actually, yeah, they have licenses as well, so companies have to pay actually to use. Yeah. Okay, so the way it works is actually, well, let's stop right here, guys. Yeah, to 12:40 right now. Okay, I'm gonna start from this one on Tuesday. Okay, and we'll probably finish the data module on Tuesday. Okay. All right. So with that, we open the today's problem. It's this one. All right. Remember we learned the modulo and integer division, right? So last week, right? So you will have to use that knowledge to solve this problem. Okay. So today is not a turtle problem. We have for a while we will probably now, yeah. So we are starting word-based problem, and then we're gonna come back to turtles probably again in module 9 and 10 when we learn looping and then the branching. Okay. All right. So it's published, guys. Could you all refresh the module view? Swap first and last. See that? You will have to use, yeah, you'll have to use integer division and modulo. Okay. All right, and then in the end, guys, when you submit, you don't have to embed this one, because embedding, you can embed Compile Explorer, but it's expensive. Probably one embed is like 300 megabytes. So for entire class, it may goes above one, even like, you know, several hundred megabytes. So I'm going to basically ask you guys to put the link instead of embedding. So otherwise, you know, it will take ages to load when everyone reply. Okay. So use Compile Explorer. This is how you do it, right? So you code it over here, and then click on share button, right? And then you can copy the short link. Copy the short link, okay? And once you get the short link, and you should bookmark it as well, because it's your own link. So that's, you can actually come back to this code if you save it. Okay. All right. All right. So let's get together and then get the plan. Okay.